Welcome to Algebra 2, Lesson 3-1, Example 3, graph a polynomial function. Let's consider the polynomial function f of x that's equal to negative 0.5 x to the fourth power plus 3x squared plus 2. Part A. How can you use the table of values to identify key features and sketch a graph of the function? So, in order to graph a function, we first want to identify key features so that it is easier for us to imagine where the graph is going, right? Especially nonlinear functions like these. So first, we want to make a table of values, and we want to identify intervals where the function is increasing and decreasing. So if we plug in values, random values for x, and then we solve for f of x, we see that the values are decreasing from here to here, right? But then, it's increasing from negative 11.5 to 6, but then it's decreasing from 6 to 6 to 4.5, and then it still decreases, right? So this is plus, minus, minus, and then it increases, and then it increases again, and then now it decreases drastically. So then we can say, okay, our graph is increasing, and then it's decreasing, decreasing, increasing, increasing, decreasing. So yeah, since we have a degree of 4, that means, and the leading coefficient is negative, that means our end behaviors are going to look down. So the graph is gonna open downward, and as x increases or decreases, x values increases or decrease, your y values will decrease. Okay, so there are points where we have a turning point, right? So here we have a turning point here somewhere, and then here your slope also becomes decreasing to increasing, and then here you have another turning point. So there are turning points that are very important in order for you to picture the graph. So first of all, we want to identify where these turning points are, right? So approximately, we can say that the turning points are between here, right? Between like here, where it starts 6 and 4.5, right? So between -2 and -1, it starts changing directions. It was increasing, and then it decreases. We don't know where it is exactly though, but we know it is changing direction, right? So we know between these two, it's gonna change directions. And then again, between these two, it's gonna change directions. And then between these two, it's gonna change directions. So that's nice to know. And so, knowing the end behaviors as well, we know that the graph is going to look something like this. But first, we want to figure out the points first. We can plot the points and then sketch a graph. But, you might be able to graph this like this, or like that, or like this. How do you know how high it is? Well, just with the 5 points, just with these points, you really don't know, right? So you just have to put your best curve out there, okay? Or you can plug in more points and see how accurate you can go. But if it doesn't require too much accuracy, it's fine if you graph it like this, a little bit off for now, okay? For now, it's fine. The point where the function has the least value over these intervals is the relative minimum. Of course, your minimum is going to be negative infinity as the graph keeps going down, right? But where it's not an end behavior, where your graph is not part of your end behavior, this is called a relative minimum in this graph. So this function has a relative minimum near 0, 2. And the point where the function has the greatest value over the interval is a relative maximum. So we have two relative maximums here. The two relative maximums are near your points that you actually graph negative 2 comma 6 and 2 comma 6, but they're not exactly relative maximum, right? They're not exactly relative maxima, but we know it's close. So right now we're just going to find an approximate points. We don't have to go as accurate as we have been doing, but that's not as important right now. That may come handy later, but right now we're just looking at the overall graph. Okay, let's look at part B. How can you use the graph to estimate the average rate of change over the interval -2 to 0, including -2 and 0? So average rate of change sounds familiar. What is it? This, in another word, this is called the slope, the famous slope. So average rate of change in polynomial functions are always going to be your y value, f of b when x is equal to b, a value that's b, minus another y value, f of a, say, when x is, say, a, right? So we're just saying, oh, these are going to be 2 points. You have 2 points, a comma f of a and b comma f of b. These are 2 points we have in the function. And if we use the slope equation, x1, y1, x2, x sub 2, y sub 2, right? You have a slope equation y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Do you remember this from Algebra 1? Yeah, it's very similar to the slope equation, right? So this is your average rate of change, okay? It's basically the slope. So in polynomials, you have 2 points, and you're just going to find a straight slope using this average rate of change, and you're going to say, oh, the change will be the vertical change over the horizontal change, right? And that's going to be your slope, and that's going to be the average of the change of the 2 points between the y values and the x values. So pick 2 points. We're going to pick -2 comma 6 and 0 comma 2. And then we're going to find the average rate of change for these two. Why specifically these two? Because those are your endpoints. When x is -2, it's 6. When x is 0, it's 2. So you're going to use these 2 endpoints, right? Where we have these 2 points. And so we're going to find the slope of these between these 2 points. And so using the average rate of change equation, your y would be 6 minus 2 and -2 minus 0. Or you can just flip the order and say 2 minus 6 over 0 minus -2. That would give you the same answer, which is -2. Okay, so the average rate of change over the interval, -2 comma 0, will be -2. All right, so we talked about some vocabulary words. Let's try number 3. Consider the polynomial function f of x equals x to the 5th power plus 18x squared plus 10x plus 1. Part A, you're going to make a table of values like we did in part A in the example as well, to identify key features and sketch a graph as a function. So first, make a table, and then identify key features, and sketch a graph. It doesn't have to be exact, just sketch a graph with the table of values you have. Part B, you're going to find the average rate of change over the interval 0, 2. Which was part B. So pause the video and see if you can do it by yourself and come back when you're ready for answers. Okay, are you ready? All right, I'm ready. So let's look at 3A. First, we're gonna make a table of values. It doesn't have to be exactly as mine, but I'm gonna choose some easy integers: -3, -2, -1, 0, 1, 2, and 3. Okay, so I have a table. And then I'm gonna compare the y values. It's increasing here, and it's decreasing between these. So somewhere between these two, there's a turning point, right? And then from 8 to 1, it's decreasing again. And then 1 to 30, it's increasing. So from decreasing to increasing, there's something going on. So there's a turning point between these 2 points. And then this one is also increasing, and then it's increasing. So yeah, it's increasing. So yeah, we just have 2 turning points in my table, and then I'm going to sketch a graph using these numbers. And so let me give you an approximate graph. This is not super accurate. I'm pretty ashamed that I can't draw a super accurate graph, but that's okay. 0, 1 could be here, and then -1, 8 would be here, and then -2, 21. So that could be 8, and that could be this could be -1 and -2, 21, and then 0, 1. Yeah, and then -3, 110. Whoa, that's like a lot. So it needs to be decreasing with a steep slope, because it's going to be -110, right? And then there is a turning point somewhere here, and then it's still decreasing here, and then it starts increasing, 1, 30. So then 30 could be over here, right? And then it keeps increasing. So 125 and 436. So I'm going to draw a smooth curve like that. So yeah, your graph will look like, and it's its leading coefficient is positive. So you're gonna have an end behavior like this. When x is approaching -infinity, this is x, right? And positive infinity here. Your y is going to approach -infinity, and as x approaches positive infinity, as it goes to the right, your y value is going to reach positive infinity. So identifying the key features, we can write that there is a positive leading coefficient with odd degree. So as x approaches -infinity, y approaches -infinity, and as x approaches positive infinity, y approaches positive infinity. Okay, good. I think we're done with 3A. Part B. Find the average rate of change over the interval 0, 2. And that is very easy. 0 is your endpoint and 2 is your endpoint. So you just need these 2 points. 0, 1. You're going to use 0, 1 and 2, 125. And so your average rate of change equation would be f of b minus f of a, basically your y values, over b minus a, basically your x values. So I'm going to use the second values first, second point first. So 125 minus 1 over 2 minus 0 would just be 62. And so the average rate of change would be 62. 124 divided by 2 would be 62. Okay, so that was example 3 and try number 3. We're going to continue with example 4 in the next video. Bye!